Chapter 3.4 and Chapter 3.5. So we're wrapping up Chapter 5, comparing measures of center. For symmetric distribution, remember we use mean and standard deviation. And for skewed distributions, we use median and IQR. Recall when dealing with numerical data, I know you guys heard this 1,000 times, but shape is symmetric or skewed. This is strictly numerical data. Center is median or mean, and spread is standard deviation or IQR. And remember, if it's symmetric, then we use mean and standard deviation. If it's skewed, we use median and IQR. The primary goal is to choose a pair of measures that is best suited for the data, which depends on the shape. So always begin with a picture. If it's symmetric, mean and standard deviation. If it's skewed, median and IQR. Where mean and median are the measures per center, and for spread, standard deviation or IQR. So here's an example. One of the authors created a data set of songs on his MP3 player. He wanted to describe the distribution of song lengths. What shape do you expect the distributions to have, and what measures would you use for this shape? So think about choosing a measure. No song can be shorter than 0 seconds. Most songs are around 4 minutes long. And then some songs, example classical music, are extremely long. So the distribution is probably right skewed, like that. It goes off and it has, the length, the number of songs that are more than 4 minutes. You might have 0, 1 minute, 2 minutes, 3 minutes, 4 minutes, and then 1 minute, 2 minutes, 3 minutes, 4 minutes, 0, and out here you might have something that's 10 minutes long. It will taper off to the right based on the number of songs that are like that. You would have a lot of songs probably that are a minute long, or some songs that are 2 minutes, or some songs that are 3 minutes, or so. And then it will taper off to the right. So it's probably right skewed. Because it's skewed and it's not symmetric, the measures would be median and IQR, interquartile ratio. So here's the actual picture of what's happening here based on seconds. We see that a lot of the data is bunched up on the left, with the longest, the typical median length being about 226 seconds, roughly 3 minutes 46 seconds. That's this tall bar in the middle here. The interquartile range is close to 2 minutes. Okay, so we have 2 minutes. Remember, this is in seconds, so each of these bars range about 100 seconds, which is about close to 117 seconds, which is close to 2 minutes. So you can't really see it here because it's kind of distorted. In other words, the typical track on the author's MP3 player is about 4 minutes, with the middle 50% differing by about 2 minutes only. Okay, in between here, there's only divisions of about 2 minutes. And notice there's some really long songs out on the edge here. Now, let's consider the mean versus the median. Skewed data and outliers affect the mean and ultimately the standard deviation. So skewed data and outliers affect the mean. Okay, so on the other hand, the median and the IQR, interquartile ratio, are resistant. They're not affected greatly by skewed data or outliers. If data is skewed to the left, it means the mean is less than the median. If it's symmetric, the mean is equal to the median, and if it's skewed to the right, the mean would be greater than the median. Keep this table handy because you might have to answer some questions. You will have to answer some questions in your homework that are based right on this table right here and the information that I'm highlighting. When comparing two distributions, always use the same measure of center and spread for both distributions. Otherwise, the comparison is not valid. If one of the distribution is skewed, then use median and IQR to compare both distributions. Because one is skewed, you would need to use the median and IQR. If the other one is symmetric, you still need to use the median and IQR because you want the comparison to be valid. So you have to use the same measure for both, even though the one that's symmetric can be the distribution can be compared using mean and standard deviation. So if both were symmetric, okay, make a note here. If both were symmetric, then use mean and standard deviation for both. But the fact that you have one skewed means you have to go with the median and IQR. And next we're going to merge right into chapter 3.5 and talk about outliers and box plots. Okay. Outliers are simply extreme data values. Now, the general rule for finding outliers is to find fences or cutoffs for the usual data values. A lower fence is equivalent to quartile 1 minus 1.5, and an upper fence is quartile 3 minus 1.5. Values more extreme than the fences are outliers. And then values less than the slower fence or greater than upper fence would be outliers. Could be less than or greater than. Finding examples. The first and third quartiles in the distribution of daily temperatures in San Francisco are 59 degrees and 70 degrees respectively. Using these values, what temperature would be considered outliers in San Francisco? So from one of them, let's go ahead and look at what a box plot would do. Box plots, hold on. So the temperature here, we would have to think about what would be I was going to go ahead and work this and I didn't. Let me explain it in a second. Just look at the data and we're going to go ahead and try to solve this problem, okay? 1 second here. Okay, so to get an answer here, we have to talk about fences first. What the heck? Not sure what's happening there, but let's see. Fences. And we can see that the lower fence based on our formula from up here, would be quartile 1 minus 1.5 times the IQR. So that would be, lower fence would be equal to 59 minus 1.5, and the IQR is, remember, the IQR is the range, the interquartile range is the lowest value minus the highest value. The highest value minus the lowest value, which is, what is that? 15, the 60 is 11, no? 11. So putting that in a calculator, you'd get about 42.5 degrees Fahrenheit, yeah? And then the upper fence would be 70 plus 1.5 times the IQR times 11. Calculator, and we get this is 86.5 degrees Fahrenheit. Okay, recall what we're doing here. This is the IQR times 1.5. That's the IQR right there. And then outliers then would be are any temperatures below 42.5 degrees Fahrenheit or above 86.5 degrees Fahrenheit. In other words, if the temperature one day in San Francisco went up to 95 degrees, that would be considered an outlier. Now, box plots help us to visualize certain summary statistics, show where the bulk of the data lie. The box is drawn from quartile 1 to quartile 3 with a line for the median inside the box. That line for the median is a vertical line or median. Whiskers are drawn to the most extreme values within the fence. Extreme values that are not outliers. Potential outliers are marked with an asterisk. Caution: box plot work well for unimodal distributions. If the data has two different modes, they tend to hide the multimodal. If the data is like doing this and then doing that, it tends to hide that information in the data, in the box plot. So here's an example of a box plot for the daily high temperature in San Francisco that we just looked at. Okay? Or similar to what we just looked at. The box plot here, we see quartile 1 to quartile 3. The minimum data value is at all the way to the end, 49 degrees. And the median value, the one right in the middle here, is 64 degrees Fahrenheit. And we can see there are 1, 2, 3, 4, 5 possible outliers. These are all possible outliers right here. 5 possible outliers. The answers are actually right here. They put the answers in for us. So to summarize this section, the key summary statistics for a box plot are minimum, quartile 1, the median, the quartile 3, and the maximum. Now remember, quartile 3 IQR, let me go back to where we did it here. Okay. Okay. IQR, right there. I'll make another note of it. IQR is equal to quartile 3 minus quartile 1. So what we're going to do, we're not going to actually plot the quartile data. Instead, we're going to go ahead and answer questions looking at the quartile data. The first few questions here are actually related to the notes, so I don't think I should answer these for you. The first, I think 9 questions are related to the model. Maybe I'll do every other one. How about that? Let's do number 2, say. You guys can read your notes here and do this. Number 2, if the mean and the median of a distribution are approximately the same, then the shape of the distribution is likely to be symmetric. Okay, likely to be symmetric. How about number 4? Because the median is not affected by the size of an outlier and does not change even if a particular outlier is placed by an even more extreme value, we say that the median is resistant. Maybe number 6. When you're comparing two sets of data, one set is strongly skewed. Now remember what we said. When you're comparing two sets of data, you have to use the same measure of center and distribution and standard deviation for both. In this case, it's strongly skewed and the other is symmetric. So for the strongly skewed one, the mean and standard deviation would be used. Okay, but for the symmetric, it means we would be using the median and the interquartile range. So since we have to use the median and interquartile range, then we have to use it for both, because for strongly skewed data, we need to use this one. And since we have to use that one, we also have to use the same one for symmetric. I'll do one more of these problems here for you. Here we go. Number 7. A dieter recorded the number of calories he consumed. As you can see, there was a mistake here. 349, 371, 398, 412. And then there was a mistake in the data, because instead of typing 419, somebody added an extra 0. When the error is corrected by removing the extra 0, will the mean change? Explain without doing any calculation. So if you think about this, the correct, if you were to put in the correct value, of course the mean is going to change. Okay, the mean will change. However, since the median value is based on what's in the middle, this data is already in descending order, and the median value is based on what's already in the middle here, the median will be unaffected. So the corrected value will give a different mean for sure, but not a different median. You can read more into it. This is the only one that actually answers the question anyway. Medians are resistant to outliers and not as affected by extreme values, but the more extreme value is, the more the mean is affected by it. Maybe I can do one more of these for you. The length of the box plot is the IQR. You guys can look up your notes for the rest. Okay, moving on to question 11 here. So the accompanying box plots show the brain size in hundreds of thousands of pixels for 20 men and 20 women. Estimate the numerical value of the medians by using the box plot. Do these men or do these women have greater variation in the brain size? Why? So below is the box plot, and we can see that for women, the median value is around 8.5, and for men it's around 9.5. Now, to find variation, we would have to look carefully at the variation between quartile 1 and quartile 3 for women. So quartile 1 to quartile 3 for women, Q3 minus Q1 is, let's see, this looks like 8.8 minus 8.2, which is 0.6. And for men, quartile 3 minus quartile 1 is, this looks like 9.8 minus 9.2. 9.8 minus 9.2, which is 0.6 also. So there's very little variation here. In other words, all of these is say greater or incorrect. All of them that say greater, there's little variation here. The variation in brain sizes between men and women is less than 0.3, indicating no significant difference. Everything that says greater women have, somebody has greater variation. That variation, if the variation is 0.3, less than 0.3, then it's a really small variation. Three histograms in 3 box plots are given below. Try to get them on one page here. And we have to report the shape of each histogram. So histogram 1 is right skewed. Histogram 2 is symmetric. And histogram 3 is left skewed. It's left skewed right there. Okay, right skewed, left skewed, and the middle one is symmetric. Now, we have to look at which box plot corresponds to which histogram. So box plot A, the first box plot here would correspond to, if you think about it carefully, look at where the data is between the two whiskers. The whiskers are symmetrical, so box plot A would correspond to histogram 2. Box plot B shows something that has a variation, is skewed to the right, So skewed to the left, sorry. That variation there is skewed to the left, so that would be box plot histogram 3. And right here we can see this histogram skewed to the right. So this would be histogram 1. Similar question to match each histogram with the correct box plot. So let's see what we can do here. Box plot P corresponds to histogram. So this is a right skewed histogram, right skewed box plot, which would correspond to histogram Z, because it doesn't show outliers. This is also right skewed. Y is also right skewed, but Y has outliers. Z doesn't have outliers, so I would compare it to histogram Z, because both show no outliers. A no outliers distribution that, am I answering this correctly? I'm sorry, no, it shows a right skewed, right skewed distribution that has no outliers. Wording. And then box plot M is also, box plot M is, to me, it looks more or less symmetric, yeah? This one is more or less symmetric. The median is a little off to the right. So box plot M, X corresponds to the M, because both show symmetric distribution that has no outliers. And finally, Y clearly has outliers. So box plot C corresponds to Y, because both show a right skewed distribution that has at least one outlier, right? At least, I'm not sure how the wording goes in my MATLAB. At least one outlier. I'm counting about 3 of them there, but at least one. Yeah. We don't know the exact number. All right, finally, question 14. Okay, the dot plot shows the distribution of passing rates for the bar exam at 185 law schools in a certain year. The 5 summary numbers, 26, 76, 87, and 92 and 99, draw the box plot. So recall that in the PowerPoint slide, I gave you what these 5 numbers are. In the last slide here, I told you that those numbers, minimum, Q1, median, Q3, and the maximum. So we're going to write these numbers first and identify what they mean. Okay. 26, 76, 87, 92, and 99. And then we're going to use what we know about the box plot to answer this question, yeah? So let's kind of label them. Can we do that? This is the minimum. This is Q1. This is the median. This is Q3. And this is the maximum. By the way, the rates are actually shown on this picture below here. I don't know if it's that important, but there's an outlier out here. So that the diagram would actually have an outlier, which kind of gave it away. You can see the outlier here. So this kind of gave away the gave away which diagram it was, yeah, because of the one outlier. That's the only one that has an outlier. So now it says to explain how you would determine where the whiskers go. Select the correct answers below and fill in the answers boxes to complete your choice. So the whiskers, the left whisker, let's see, the whiskers extend. Not sure how they want us to answer this. Let me see. No, actually, the only one that answers this, the whiskers don't extend minimum and maximum. This is incorrect. The whiskers extend the left outlier is incorrect. Remember, outliers use asterisk. The whiskers do not identify the range. So the whiskers extend the most extreme values to the not potential outliers. The left whisker extends to the smallest observation that is greater than or equal to, and in this case we have to figure out that is the quartile IQR is equal to 92 minus 76. Let's put that in a calculator. 92 minus 76 to give 16. And we would take that Q1 value, so the left extreme value would be smallest or lowest fence, would be equal to 76, the Q1 value, minus 1.5 times 16. 76 minus 1.5 times 16, which is equal to 52. So that is greater than or equal to 52. And then the upper fence is equal to 92 minus 1.5 times 16. I have my calculator here, which is equal to 116. 116.